Hello, good evening, everyone, and we are live here in our YouTube channel. This is an online tutorial for maths and science. Good evening, everyone. Good evening, good evening. Thank you so much for waiting. Um, Wait, good evening, good evening. Uh oh, wait a minute. Okay, yep, that's, yep, here we go. Good evening, everyone. Welcome to our live stream here in our YouTube channel. Thank you so much. Oh my goodness, I'm burping. Good evening, everyone. Good evening. Thank you so much for being here. This will be a very quick live stream that we will be doing tonight. For the reason we have some things to do after which after this live stream. Okay, cool. I don't think I could move my microphone. Yes. Good evening, everyone. Welcome to our live stream. Good evening. So we will be talking about maths and science tonight, and most probably our uh, first how should I say it? Our first topic will be on science. We will continue to work on functions. So, yes, that will be on functions. Thank you so much for our 4 viewers tonight. Thank you so much. Please don't forget to like and share as well our live stream. All right, let me just pull out. Okay, let me check. All right. Cool. All right, cool. So we will start off with um, our first topic tonight. We will continue on functions and what are functions and all those things we have discussed last time if we substitute. And I have also released a video with regards to functions. So please do check that out. And as well as for hopefully this week, I'm trying to complete a what is this? An art episode for this week. So let's see what is the outcome of it. I hope that you would like it, or most probably we will do a music. So stay tuned for our next video that will be released in our YouTube channel. Okay, cool. All right. So we continue with our discussion on functions. And the last time we talked about substitution. Function is like a machine wherein you put in your input and then you'll get an output. Now, our live stream for today will be about inverse functions. So when we talk about inverse functions, these are functions that takes and input and produce an output, right? So that's function. So with the inverse of a function, it does the opposite. That's why it's called inverse. It describes how we get from the output. So it's the opposite. So if it's if the function is from the input, towards your output. Inverse is how we get from the out sorry how we get from the output to the input. So it's the other way around. So if we go back, let's say 2, that's your input, and we multiply it by 3, our output will be 6. So this is our input and this is our output. So the inverse would be, what would you do with 6 so that you will get 2 back? So if your f of x is 3x, that means that if you do the inverse of it, so inverse, you'll have the negative 1 on top. So the inverse of it will be your x divided by 3, right? So that will be the inverse. So if we talk about getting the inverse, that means that whenever we put in a certain function, if you would see the operation, inverse would be always the opposite of whatever operation that you have. So let's try a few and see the trend of how your inverse would look like. Okay, even if we don't solve it, even if we don't solve it, then we would be able to know what is the inverse of a certain function. As I have mentioned, it's always the opposite. Let's see. All right. So let's say, for example, you have f of x equals x plus 5. So the x is your input. You add a 5, you'll get an output. Therefore, the inverse of this will be x minus 5. You will get, because x here now is your output, so when you subtract 5, you will get your input back. So the other one is f of x is, let's say, 3x minus 1. So the x here being multiplied to 3, and then you subtract 1. So the inverse here would be, you add 1 to x and then you divide 3. So x is your output, and the inverse, it will be the reverse process. So if, let's say, you have an f of x where you have the root of x, oh no, the root of x plus 3, this will be the inverse of this. Since you're getting the root, so you take the root of your x, you add it to 3, you'll get the output. Hence, your output is subtracted to 3, and then you square it, you'll get the input back. Okay, so it's the opposite process. So if it is 1 over x, therefore your inverse would be, so whatever is 1 divided by x is your output. So hence your output, 1 divided by x, would still be your input. Why is this so? Because if a function is the same as the inverse, it is known as the self-inverse. So it is also 1 over x, or 1 minus x, is also a self-inverse. All right. Cool. Any questions so far with our inverse function? All right. If there's none, then we will continue. I'll give you another example, and this time we will solve it. Okay, we will solve it as, how do we get the inverse of a function? So let's say you're given the function of x equals x over 5 plus 1. And you're asked to find the inverse. So you're asked to find the inverse of your x. Now, when you do this, a function, which is your output, is your y. All right, it's your y. So when you get this, the value of this, then it should be y equals x over 5 plus 1. Now, when you do this, you make your x the subject. All right, we will make our x the subject. So first you move 1 to the other side. That's y minus 1 equals x over 5. And then you transfer 5. So that will be 5 times y minus 1 equals x. Therefore, our inverse function is, you just need to distribute that, 5y minus 5. Okay, so that is your answer. Cool. Now, let's have a little bit of, how should I say it? A bit difficult question. Not that much difficult though, but this is always a challenge question that most students would get. So let's say, for example, you have a function f of x equals x plus 1 over x minus 2. And you're asked to find the inverse. Okay, so the first step is you make your function, because this is y, so y equals x plus 1 over x minus 2, and then make x the subject. You make x your subject. So you move first the one in the bottom, or your denominator, to the other side of the equation. So that's y times x minus 2 equals x plus 1. And then you distribute y. So you'll have xy minus 2y equals x plus 1. You put x on all on one side. So that will be xy minus x equals 2y plus 1. You factor out x. So x equals y minus 1 equals 2y plus 1. Therefore, x is 2y plus 1 over y minus 1. Therefore, your inverse of your function is 2x plus 1 over x minus 1. That's your inverse. So you just need to make your x the inverse. You just need to change your y to x. All right, cool. Let's see. Are there any questions so far? Any question with inverse? Question. All right. Let's have the last two. Let's have the last two examples before we proceed to science. Okay. So if you have the function 2x plus 1 over 3. So first step would be you get its inverse, and then if you're asked what's the inverse if x is a 4. So first is you have y equals 2x plus 1 over 3. You make your x the subject, so that will be 3y equals 2x plus 1. So that will be 2x equals 3y minus 1. So x equals 3y minus 1 over 2. So that will be the inverse would be 3x minus 1 over 2. That's the inverse. And then you just need to substitute your x with the value that you're asked. So for this case, it is 4. So that's 3 times 4 minus 1 divided by 2. That will be 12 minus 1 divided by 2. That will be 11 over 2. So our inverse here is 11 over 2. Cool. Okay. So that is how you do your inverse. Inverse of your function, you take its reciprocal and, you take its, take y and x, make your x the subject of the equation, and then exchange x, make x your y and y to x, and then substitute your 4 value. All right. Let's move on to our last and final question for functions before we proceed to science. So find the inverse of your x. So find the inverse of your function x. Okay. Again, first step is you change function to y. Rearrange the formula where x becomes the subject of your equation. So that's y times 2x minus 1 equals x. Distribute y, so that's 2xy minus y equals x. Transfer x to the left side and all the y's to the right side. So 2xy minus x equals y. Factor out x, so x becomes 2y minus 1 equals y. Therefore, the inverse of this would be just exchange um, just exchange x to y, y to x. So this will be x over 2x minus 1. So that will be your answer. Cool. All right. So that is your inverse. Now, moving on, let's proceed to, is there any other question for inverse? Inverse function. We have here, wait. Thank you for our 5 viewers tonight. If you have any questions so far, please do type in your questions in our chat box, and we will try to answer all of them as much as we can. Hello, good evening. Thank you for our 5 silent viewers tonight. So if you just wanted to listen to relax, please do stay and enjoy the music. Okay, so now we will proceed to science. Oh no, I think my. All right, so we will proceed to science right now. And if we talk about science, then how should I say it? How should I put it in words? If we talk about science, there are a lot of things that you could actually learn from. And one of my favorites, actually, this is my favorite, is chemistry. That's my favorite, if you would ask. So, if you have, for the love of chemistry, for the love of chemistry. So, we will be talking about a balancing equation tonight in chemistry. Cool. Thank you for our 5 viewers tonight. I hope that you would actually just drop a comment. I would appreciate that. Appreciate it. All right. So I guess there's no those no questions. So we will proceed with a balancing equation. So before we discuss how to balance equation, first we have to understand what is a chemical equation. So when we talk about chemical equation, a chemical equation is described as where the chemical change happens. So you have your reactant part going through reactions and all those things, and then you get the products. So that's the part of your equation. So on this side, A plus B, on this side will be your reactant, and then you have C plus D, which is your product side. So that is how a chemical equation is. So when we talk about reactant, reactant is the chemical or the elements that you start with before the reaction occurs. So think of this as your raw material. Okay, so it's always written on the left side of your equation where the arrow begins. While your product side, which is your C and D, this is the new chemical elements which is formed from or by the reaction that you have. So this is written on the right side of your chemical equation. So when you see a subscript, you this one means that subscripts and coefficient. So what's the difference? So if you have H2O and comparing that to 2H2O, okay? So this one is your subscript. This one is your coefficient. So what's the difference between the two? When we say subscript, this is to show you how many atoms of an element, okay, subscript, are in a molecule. So if you have H2O, it means that you have 2 atoms of hydrogen and 1 atom of oxygen. That is what it means. But if you have a coefficient, the coefficient is the number that shows how many of this molecule are there. So that means that if that's 2H2O, that means that there are 2 water molecules. So it will look like this: 1 water molecule, another water molecule. So 2. But this one is just H2O. So you will have H2O. That is your chemical equation. So that's the difference between a subscript and a coefficient. All right. So let's say, for example, on the note or on the discussion of H2O. So how is your H2O formed? So it is formed by reacting your hydrogen, which is H2, plus your oxygen, which is O2, to form your H2O. Now, this one, if you would notice, in the law of conservation of mass, it says that in a chemical reaction, your matter is neither created nor destroyed. So, in other words, the number and type of atoms going into a reaction must be the same as the number and type of atoms coming out from the reaction. So that is what it means by conservation of mass, which means that the law of conservation of mass states that your reactant side and your product side should be balanced in terms of number. So this one, as you could see, there are two H2 here, two H2, but O2 has two here and only one O2 there. So that means that there is a missing oxygen. So how do we make sure that this is balanced? By writing coefficients. We have to ensure that we have the same number. So since you have two here, we will place two there to make that two oxygen. And then since that becomes four now, we place two as well on that side. So two of your hydrogen. So two of this. All right. And then O2. Hi, Maha Blanca. And this will be 1 and 2. So the number of hydrogen that you have here will be the same with the number of hydrogen on your product side. Number of oxygen would also be the same with your number of oxygen on the product side. Hello, Maha Blanca. We might just have a 30 minutes live stream tonight because there are no questions at all. And yeah, so most probably that will happen. All right. So that's why, because there's not much of a question. And yeah. All right, cool. So moving on. So let's have another example. Let's say, where's kernel? I don't know where's kernel. Let's say you have CH4 plus O2 will form or will produce carbon dioxide and H2O. So then you have to check whether the equation is balanced. You have one carbon here, okay. One carbon on the product side, that's good. I'll place it in the middle, it's easier. And then hydrogen, you have 4 hydrogen here, and then you have 2 hydrogen on the other side. And your oxygen, you have 2 here, and you have 3 on the other side. So technically, your hydrogen and your oxygen is not balanced. So we have to make it balanced. We have to balance it. So how do we balance it? Since there are 4 hydrogen and 2 hydrogen on the other side, we will multiply this by 2, which makes that 2 oxygen as well. So 2 oxygen on H2O and another 2 oxygen on carbon dioxide means that there are 4 oxygen on your product side. This becomes 4. Therefore, since there's only 2 here, we'll multiply that by 2 so that we'll get 4 as well. So hence, the balance equation for methane, the combustion of methane, will be CH4 plus 2 of O2 yielding carbon dioxide and 2 of your H2O or water. So what's the rule? One is matter cannot be created or destroyed. Subscripts cannot be added or removed or changed. You can only change the coefficient. Again, that is your coefficient, the number before the molecule. Coefficients can only go in front of a chemical formula and never in the middle, never at the end. So that is how you do it. All right, cool. Any questions so far? So that is how you balance it. Another example. I'll give you another example. And I guess this is where we would end. All right. Okay. So you have here KClO3, that's potassium chlorate, giving you a product of potassium chloride plus O2. So then you have to check whether the equation is balanced. So you start with K. Your K here is 1. Your K on the product side is also 1. That is balanced. Cl is 1 here, and Cl on the other side is 1. That's balanced. However, oxygen is 3 here, and oxygen is 2 here. So to make 3 and 2 balanced, that means that you have to multiply one side with 2 and the other side with 3 so that you'll get a 6. So you multiply this with 2, you multiply that with 3, you'll get a balanced oxygen of 6. So this will be 3, that will be 2, that will be balanced. However, K and Cl on the reactant side has been affected. It became 2K and 2Cl. So then you have to put 2 there, and this becomes your balance equation. All right. Okay, so that is our equations. So. Any questions so far? Yes, you remember. I remember the day we first met in September. Mm-hmm. Any question? Yes, it's balancing equation. Questions so far? Question, clarification. Any question? So many questions. 9. What 9? What is 9? And the answers are with you. So many questions. A year 9. Okay. Thank you for our 6 viewers tonight. Yes. Questions so far before we end our live stream? Wow, this is the shortest live stream I've ever had. Just for 30 minutes. All right. Not the shortest. Really? What is the shortest I've ever had? I think this is the shortest. All right, let's have the last and final question, final example. One of the shortest. One of the shortest. Okay. So let's say we have Fe2O2. That's iron 3 oxide plus H2SO4, sulfuric acid, yielding Fe2, that's a subscript, SO4 3 plus H2O. So here, this will be a bit of a long equation. So you have to be careful when you do things like this. So here, wait, can I move it? Can I move it? I'll move it here. Fe2O3 plus H2SO4 yielding Fe2SO4 3 plus H2O. Okay. So first step is you have to identify all the atoms that you have, or all the elements from your reactant side and your product side. So you have Fe, there's 2 Fe here, and you also have 2 Fe there. Okay, and then you have oxygen. You have a 3 oxygen plus 4. All right, you have 3, and you also have, okay, what you can do is you deal SO4 as SO4, so that, because when that SO4, that sulfate reacted, it's still SO4 anyway, because it's an ionic compound. Okay, it's a polyionic. So we have oxygen 3 here, and we have 1 on the other side. Okay, and then H2, and then you have H2 as well on the other side, and then SO4, you have 1 here, and then you have 3. So you can actually like determine which one to start off with. So I'd rather start off with oxygen. So I will multiply my oxygen here by 3 so that it will be balanced. So I'll put 3 here. That will make my H2O 3 as well. So since I'm making my H2O3 here, that's 3, that means that I have to multiply 3 as well on the other side. So then this, since this is being multiplied by 3, that automatically multiplies SO4 as well as 3. Hence, my equation is balanced. So that's it. All right, cool. Any further question? All right, cool. If there's no question, then I would say that will be all for tonight. Thank you so much for being here. Thank you, Ma Blanca, for staying. Thank you so much. And I guess that will be the end of our live stream for tonight. This is short and sweet live stream. Oh, yes. And I will see you next week, Tuesday, once again, for another maths and science topic. I'll be releasing, most probably this Saturday, I'll be releasing an art, or it would be no game. No game for tonight, Maha Blanca. Otherwise, it will be just 2 or 3 of us playing. So I'll see you next week. And yes, so same time, same channel. This is your teacher, Teacher Maria, saying good night, God bless, and see you next week. Bye-bye. See you next week. Good night.